So all it's asking is to find the six trig function, I keep saying six, sorry. You're going to find sine, cosine, and tangent for angle A, sine, cosine, and tangent for angle B. And I use colored markers, people online, so if you can't see something, let me know, because I just want to make sure you can see what I'm doing. So, Rob, what did you get for the sine of A?
36 over 85.
36 over 85. So we know that sine is going to be opposite over
Hypotenuse.
opposite over hypotenuse. So we got 36 over 85. Cosine then is going to be what?
77 over 85.
77 over 85. And then our tangent is going to be
36 over 77.
36 over 77. Now, none of these can be reduced. I could put them in decimal format, but I'm going to leave them just like this because this gives me an exact number, okay? So, Brady, what did you get for the sine of B? 77 over 85. What about the cosine?
36 over 85.
And the tangent?
77 over 36.
So, does everybody see the relationship? Look at those, the sine, cosine, and tangent of both those angles. Can anybody see a relationship going on there?
Sine and cosine are the same. Cosine and sine are the same. Tangents are just flipped.
So the sine of this angle is the cosine of this angle, right? So it's just kind of flipped as it looks as you're looking at it. And then we have the tangent. Now, what would I do with these if I ask you to find the cosecant, secant, and cotangent of these? All I'd have to do is just go through and just, do the inverse of all those. Would I even need to look back over here? Not really. I could just flip them automatically and not have to worry about it. So looking at those functions, if I know sine, cosine, and tangent, then I could automatically move on to the next one. So let's look at the, I don't know why I'm wanting to write this down. So look at examples 2, 3, and 4. So here on number 2, you've got find the 6 trig functions for value of angle 60. So you're just looking at angle 60, the 60-degree angle, and you're finding the 6 trig functions. Here you're finding the 6 trig functions for an angle 30. And then here at the bottom, you're finding the 6 trig functions for 45. And if you can't scroll up any, but I'll put the 45 to the side so you can see it better.
What is the number that's opposite of 60 degrees there?
Oh, sorry. This is, square root of 3. This is a 2 and a 1. Uh-huh. So the 60-degree angle at the top, sine, cosine, and tangent. Who wants to tell me those? So Emery, what have you got for sine for 60 degrees?
Square root 3 over 2.
Square root of 3 over 2.
1.
So opposite over hypotenuse. Sorry.
Cosine 1 over the square root of 3.
1 over the square root of 3.
Tangent square root of 3 over 1.
So then cosecant is going to be
2 over square root of 3. Square root of 3 over 1. 1 over square root of 3.
Now, these are correct, but the fact is we can't have a radical in the denominator. So we've got to rationalize. And in case anybody, I want to do the cosine here is equal to 1 over the square root of 3. And to rationalize this, you need to multiply by the square root of 3. Because I know when I do square root of 3 times the square root of 3, square root of 3 squared is going to be square root of 3 squared is going to be 3. So this is going to be 3 square root of 3 over 3.
Why is that one square root of 3? Because it's cosine. The opposite. Be over hypotenuse. Be over 2.
So it'd be 1 over 2, adjacent over hypotenuse. Yeah, it would be. Sorry. My battery is running low. Sorry, people. I'm going to plug you up. So for the cosine there, let's leave that one for the cosine of 30. How about that? No, for the, sorry, cotangent. Cotangent correct? The tangent's going to be opposite over adjacent, so the cotangent will be adjacent over opposite. So yes. So now our cotangent, instead of being 1 over square root of 3, is going to be square root of 3 over 3. Okay? But we have a problem also with the cosecant. So we said that the cosecant is equal to 2 over the square root of 3. So to rationalize that, I have to multiply by the square root of 3 over 3. Square root of 3 times the square root of 3 is going to be 3. So we've got 2 square root of 3 over 3. Official, this is correct, but remember, if you're thinking about it and you say, okay, then I need to make sure I've got the denominator rationalized. So I have to get that radical out of the denominator. So what about the trig functions for 30? We know the sign's going to be opposite over adjacent, right? So the sine of 30 is the same thing as the cosine of 60. So it's going to be 1/2. The cosine of 30 is going to be the same as the sine of 60 because it's going to be the adjacent over hypotenuse, right? And that's the opposite over hypotenuse. So this is the square root of 3 over 2. What's the tangent going to be? Square root of 3 over 3 because it's going to be 1 over the square root of 3. Then our cosecants are just going to be the flip. So we've got 2 square root of 3 over 3. And then this is going to be square root of 3. Now 45, 45, 90. So the tangent, the sine and the cosine are both going to be the same, right? So the sine's going to be sine of 45, cosine, tangent. So sine's going to be opposite over adjacent. So that's 1 over the square root of 2, which is going to be square root of 2 over 2. Then the cosine is going to be adjacent over hypotenuse, which is the same thing. Right? Square root of 2 over 2. Then tangent is going to be tangent's going to be opposite over adjacent, 1 over 1, which is going to equal 1. Then what's going to happen? Sine, the cosecant is going to be square root of 2. The secant is going to be square root of 2. And then the tangent is going to be 1. So if you make out, as you see, this little chart that I've written all over. If you know this little chart, this should be able to help you out because what you've done is you just figured out your unit circle by doing what we just did. Our angles coming off of our origin, we have a 30, 60, and 90-degree angle, and then we have a 45-degree angle. So those angles are going to be pretty much what we've got going on with, those are your major angles you need to know. So when we start doing some other things with them, knowing how to manipulate these and come up with these is going to be the best thing. Now, what are cofunctions? So what is A over C? Look at this bottom chart here. What of A is A over C?
Sine.
The sine, because it's opposite over hypotenuse, so the sine of A over C is the same as what of B? And we just talked about this. The cosine, right. So these are cofunctions, and that's all it is. It's just saying that if I know that the sine of a 60-degree angle is going to be 30 or whatever, then I know that the cosine of a 30-degree angle, the opposite is going to be 30 degrees, whatever. Does that make sense? So the sine of A is A over C. That's also going to be the cosine of B. What of A is A over B? So here's A. So A over B is going to be opposite over adjacent, which is tangent. And then that's the same as adjacent over opposite for angle B. What is that? So for angle B, if it's adjacent over opposite, it's going to be cotangent. So then angle A, if we have C over B, hypotenuse over adjacent, what do we have? Secant. So the secant of A is the same as what for B? Which is going to be opposite over hypotenuse.
Sine.
I'm sorry. C over B, which is going to be hypotenuse over the opposite. We're at angle A, and you've got hypotenuse over adjacent. What do you have?
Hypotenuse over adjacent. Secant.
Is secant. If you're at B and you've got hypotenuse over opposite,
Over opposite.
hypotenuse over the opposite is what? I'm sorry, cosecant.
Secant.
So those are called cofunctions with those two angles. So knowing those. And these are some cofunction identities. So if you know that the sine of A is going to equal the cosine of 90 degrees minus A, cosine of A is going to be sine of 90 minus A. So we have sine and cosine, which are going to be cofunction identities. We have secant and cosecant, which are identities, and then tangent and cotangent, which are identities, cofunction identities. So if we look at this one, the sine of 9 degrees, what would be its cofunction? So write this in terms of its cofunction. So the sine of 90 degrees is going to be
90
cosine of 90. So it's going to be the cosine of 91 degrees. So for B, if we have the cotangent of 76 degrees, then it's going to be and then the last one down there is going to be the cosecant of 45 degrees. And this is going to be the secant of 90 minus 45. Now, these functions of angles and acute functions, I gotta remember to erase this. Sorry. When we're talking about reference angles, we're talking about an angle that's written for an angle theta. The reference angle is written as theta prime. And it's an acute angle made by the terminal side of the angle theta and located in the y-axis. The x-axis, sorry. No y-axis. I'm just totally. I want to do this and I can't do that.
What was the first two words of blank?
The reference angle for an angle theta is written as theta prime. Is the positive acute angle made by a terminal side of angle theta and the x-axis. So as you see here, it's always going to be the terminal side here. So in quadrant A, you can see that quadrant 1, this first one here, you have your, what is this called here? We went over this last week. What is this called? What part of the angle is that?
The initial side?
That's the initial side, and this is your terminating side. But do you see the angle theta is going to be in reference to this, the distance from here. So in this one, in quadrant 2, we're looking at this angle. This is my reference angle. So in quadrant 1, usually your reference angle is your same angle that you have between 0 and 90 degrees. In quadrant 2, you're looking at between 90 and 180 degrees. So theta here is going to be 180 degrees minus theta prime. Right? Because whatever this is here, and this is theta prime, it's going to be 100 degrees minus theta prime. So in quadrant 3, what's your reference angle going to be?
All the way down.
So how do we find theta prime in quadrant 3?
270 minus theta prime.
We gotta reference it all our x-axis. So here, remember, I wanted to do 180 minus this, and that gave me this angle. Or minus theta, sorry, and that gave me this reference angle, made me this. So here, I'm going to say 180 plus my theta
Equals that.
is going to equal what this angle? Is that my reference angle?
So it would be just 180 plus theta equals your angle.
180 minus theta is going to give you a reference angle, right?
For the second one, for quadrant 3 though,
For quadrant,
2, it'd be 180 minus. Quadrant 3 it should be 180.
180 plus whatever your angle is. Excuse me, it's going to be
180
your
plus
angle,
reference
your angle theta minus 180. So we're wanting to know what this is, right? And this is going to be bigger, so theta here is going to be minus 180 degrees. And it's going to give me what this is. So in this one, theta prime is just going to equal theta, whatever that is. In this one, we're saying 180 degrees minus theta is going to give us theta prime. Here we're saying theta minus 180 degrees is going to give us this. And then this one is going to be the one that we're looking at here. Theta prime is going to equal what?
360 minus theta.
360 minus theta. It's going to be theta prime. Because if I know that this is going to be a 60-degree angle here, then I know all of my functions, right? How to pretty much, because that's the unit circle. If I know that I've got a 30-degree angle here, then I know all my functions for that circle, for that angle, because that's going to be the same as whatever that angle is above 180 degrees. So if it was a 210, that's going to be 30 degrees above, right? So if this was a 210 angle, then my reference angle is going to be a 30-degree angle. So that's what you're looking for here. That's what you're looking, those reference angles are going to be good because hopefully a lot of them are going to be 30, 60, and 45 degrees. And so you can reference pretty good how you're doing your functions and things as we're going through. Now, we are looking at all of these. I am not going to be going over each one of these examples, and so that's why I sent them out to you. If you want to go through them and then log in with me on Wednesday, you can do that. But these are going to be, as they go through, how we're doing these. Your angle of elevation, when you're talking about these, remember that you have your initial side. So when we're going up counterclockwise, that's our angle of elevation. When our angle is initial side and it's going clockwise, that's our angle of depression. Okay, so when you're looking at these different angles, and make sure when you're doing these that you're drawing pictures. When we are doing bearings here, so it says that I have a bearing of single angle is given such that 164 degrees is the bearing measured clockwise direction from due north. That means that we are going facing north and we're doing clockwise around 164 degrees. It's not a negative, it's just, this is how aviators, when they're flying, will tell which way they're going to go. They're not going to go and do a negative angle or whatever. I'm going clockwise or I'm going counterclockwise. So here, if you're doing north, then you're going due north, from due north, then you're going whatever angle you have here, degrees. Then pretend you've got a north-south line and you're here, sitting here at X. And so what if it says that you're using acute angle to show the direction? So what if I have north 42 degrees east? So I'm standing in the center between north and south, let's say east and west. So I'm going north 42 degrees east. Or I'm going south, which I'm going to turn around and go south, and then I'm going to go east or west from south. So this would be south 31 degrees east, south 40 degrees west, and then north 52 degrees west. So you see there's different ways. If it doesn't tell you that you're going ever how many degrees east, west, south, whatever, from north, you always assume that you're going due north and then you're going that many degrees clockwise from there, unless it's labeled you're going north or south. And there's problems working on from there too. Okay? So this Wednesday, I will be available at 12:20 to talk with anybody, and from 12:20 to 1:15 to work on any problems. These are good problems to work on. If I come across any that you don't need to know or need to know how to do, that's fine. I am going to be setting up your project, and hopefully I would like to start it after everybody comes to class, but then that's getting people together to do stuff. So we may have to start it before that, and then it's in 2 parts. So maybe I'll do the first part, then add the second part y'all can do after everybody starts joining us.
Is this notes online?
They are on Blackboard.
Okay.
So these notes that I just went over are posted in Blackboard. If you look under course content, I think I've even done it saying class notes are here. So you can see it pretty good. So any questions about today?
When's our first test meeting?
It will be open, right now I'm planning on opening it next Friday, the 11th. So that's why I said you got to work ahead. You got the notes you can move ahead with, come back with any questions.
So that's when all the homework is due?
Homework is due all on the 11th.
Okay.
Yes. So I will be available on Wednesday from 12:20 to 1:15. And then the following Wednesday, the 9th, we will be having class on Teams. And so I will send y'all directions how to do that. Because I need to, we need to get that get us all done. Any questions online? Anybody there? Everybody left. Hello?
No, ma'am.
Thank you.
Yeah, I'm all good.
I'm all good. Okay, thank you. Okay. I shall